You can upload screen here. And I assigned this, and I just wanted to briefly go over it and explain a few things. Okay, so because we're considering 5 different players here. I don't know if you noticed on the left side, I typed them all into a different column, right? L1, I put Anna on L1 and then Patrice on L2 and so forth. And these are the number of games that have been played. So it's almost like in the past I would have just given you one table, right? And you type it all in. But now we're comparing various different players over 10 games, right? So for Anna, we find the range, right? Subtract the max and the min. We find the mean and standard deviation. I just typed that into one variable stats, and it's just one column, right? It's just those are the points that I'm keeping track of. And then we do the same thing for the other players. And so just by observation, I don't like what I highlighted is here. Watch this. Morgan has a big range between scoring high and scoring low, like a day where Morgan didn't score very high. That difference is 29 points. That's a significant difference compared to everybody else, right? Almost 30-point difference between a low and a high day. And watch what happens to the standard deviation. It's 9.02 compared to all of the other ones. That is significantly higher, right? So a big standard deviation, a high range will also have a higher standard deviation associated with it, meaning that player is not very consistent, right? You're not consistent. The same can be said about your scores. We take all of your tests and we find the mean and the standard deviation. If you have a high standard deviation, that means that you're not consistent. You might be scoring low here and then high on the other, and all over the place, and everything in between, right? So that is something you need to watch out for. And then on the flip side, look at the player with the lowest range. That would be Paige, right? Paige, the range is only 2. The difference between the highest and the lowest score is only 2, right? So not a whole lot of fluctuation variation. So watch what happens to the standard deviation. Standard deviation is the lowest of all players, right? So Paige has the lowest range, which correlates with the lowest standard deviation. So they go hand in hand, okay? Um, and so what can be said here is that Morgan is probably the most it is in this case the most inconsistent player, and that Paige is the most consistent player. That is, you can state that right away by looking at the range, looking at the standard deviation. Uh, Furthermore, what one could say, there's one question here, uh, right? Which player has the greatest percentage range? And that would be Morgan. Which player has the least? That would be Paige, right? I answer that there. How do the standard deviations of these players compare? And I mentioned that just now. Okay. Which player has the lowest standard deviation? That would be Paige. And what it says is data is clustered, or the scoring, right? The scores are close to the mean, more consistent, lowest standard deviation. Okay. Based on the table, which player has the potential to shoot most poorly? Which player has the potential to shoot most successfully? Okay. And you would have to say it's Morgan. Okay. Morgan has the highest any player has ever scored, right? 48 is the highest, but also has the potential to score the lowest, right? 19 is pretty much the lowest. I'm looking at the numbers. 19 is the lowest. So Morgan has potential for both scoring the highest, but also scoring the lowest, which is another indicator of inconsistency. Okay. If you were a coach, which player would you substitute into the game and why? Now, you kind of want to look at the average, right? The highest average is usually a good thing overall because you are scoring high, right? So the highest averages would be, right, 36, 36, and 36, right? There's three players with the highest average. But out of the highest average, you want to pick the player with the lowest standard deviation. And that would be Patrice, right? Because, right, they're all very close to the 36 range, sorry here. But this player star has 3.35 as standard deviation, 5.88, and then there's Patrice with 1.5, right? So that's the one you would want to go with if you were a coach. That's kind of what we'd want to try to do is, yes, look at the average, but also very much look at the standard deviation, especially when you have choices to make or when you have to, right, pick one. How would a set of data with low standard deviation differ from a set of data with a high standard deviation? It's basically, I'm saying the same thing over and over again here. Okay. Data with, this is on page 9, by the way, of your booklet, with a high standard deviation will have data points that are scattered. You can say widespread, comma, further from the mean. Okay, so yes, it's going to be spread out, it's going to be scattered, and it's going to be further from the mean. All of those are true. Okay, data with a low standard deviation will have points closer to the mean, sorry, mean, clustered around the mean. Okay, so those are things you need to definitely keep in mind at all times. So if you can look at it graphically, right? You can just talk about it, what it would look like when it comes to sports in particular, or test scores or whatever. We're talking consistency, right? You could have also talked about the range, that a high standard deviation will have a higher range, a low standard deviation will have a smaller range. Okay, so there it is. I just wanted to go over it one more time. And now we're going to watch a video, an 8-minute video. Okay, so let me just pause this